Clap, 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 clap. Hi, so this will be the story of how me and a group of Java engineers decided that we want to have fun with stuff commonly known as DevOps engineering. You may think that you also want to go this way, or you may be on this path, or you may wonder what got into our heads as we became, I think, what is nowadays known as being cloud engineers, so a programmer who knows this stuff a bit at least. So let's start by answering this question, why? Why did we do it? Why you may consider doing it? So one small thing, just to get it out of the way, if you think that perhaps your application would benefit a lot from becoming cloud native, which I define as making really good use of the cloud, not just running somehow, but making full use of the cloud infrastructure, then this may be a reason, because if you have knowledge of the infrastructure in one person and knowledge of the application domain, goals, in another person known as programmer, this may not work out as great in my experience. Because Conway's law kicks in, and this will probably show. This is a small thing, really, I think. Really, what's most important stuff is also based on my experience. DevOps engineers, as I've worked with them, typically lack interest in the domain, the application they're running, only what sticks out of them. So this port sticks out, this communication sticks out, this what interests me. Inside, what it does, no interest. And customers, great. We have to make money with it, okay. They may be interested in saving money, cutting cloud costs, but that's not exactly the same as making money, right? And if you push them towards learning this, they would rather venture into DevSecOps, also a buzzword some years ago, a few years ago, maybe not that lately. Anyway, they will tell you that there's very important stuff that you don't understand that they need to take care of, or will pay millions, go to jail or something. Basically, at some point, DevOps engineers, quite like security engineers, will hold the whole company ransom because of the importance of their perceived work. And this you may find problematic, as I did. Then there's, if you really think of it, before we get into it, so I've seen a model where, and this is actually one of the better models, where each product team gets one DevOps engineer. So we have cross-functional teams. Great idea, really. But and like I said, I really seen this happen, even though it may sound a little crazy. The DevOps engineers will soon, across the teams, will soon form a guild, which makes sense. A guild from the Spotify model is an organization within a company that should be dedicated to knowledge sharing. But I've seen this DevOps guild becoming a clique, and then a team, really, with its own leader, its own priorities. And soon, if single DevOps engineers didn't do it already, the DevOps guild will hold the company ransom, or perhaps come up with a great idea. Let's create a single infrastructure for all, because every application is the same, right? Every application is just some Java with some HTTP sticking out, perhaps some Kafka connectivity. So let's make it once for all, and it will fit all, right? As it spins out of control, they weaponize the little concept known as list privilege principle, which makes sense, but if taken to unhealthy extreme, will strip everyone, but someone who has DevOps in their role, from any access to cloud, or near any access to the cloud. And soon there is really no way out of it. And then Finally, as we have a single DevOps engineer per team, vacation and sick days make painfully obvious that there is a single point of failure in the team, right? Sometimes it's alleviated if DevOps from another team knows how to fill in, but I didn't find it great, personally. So there's this little concept known as business awareness. It's the ability to see the bigger picture beyond your day-to-day work, why we do it, to actually care about the customer, say. And as I see it, of course, your mileage may vary, and I will repeat this a lot probably. Software engineers are, it's okay for them not to have any business awareness while they're junior. So junior developers are okay to just come to work, make some code, be happy with it, don't care about anything at all. But as you get to some perhaps regular, latest senior, you are expected to have this business awareness and work more closely with project team. DevOps engineers, not so much. But your mileage may vary. And it really boils down to this quote that I think puts this up quite nicely. I'll let you read it. So it's just from a blog from the internet. You may argue it's not really that important, but I think it's really to the point, which is why I've chosen this one. If you Google DevOps, it's not a job. DevOps is not a position. DevOps is not a title. This idea is actually quite widespread. I'm not coming out with this right now. For example, beyond this one, Tomasz Nurkiewicz also has a post about this concept. So you may decide you may want to do something with it, perhaps embrace the DevOps culture. And let's get also this out of the way. If your DevOps engineer recently started to make you want to call him SRE engineer, that's really not much of a difference. I mean, they don't tarnish the word DevOps as much if they do. And SRE is a great concept, and if you go this way, there's no way out you will be reading books about it. And because I'm not going to teach you anything today. If you are to learn about DevOps, it's not a great talk. Let me also tell you this. I'll tell you just that it's possible and how we did it, to state that it's possible. So if you're going to go this way, you will need to do a lot of reading on your own, and SRE book, the book by Google about how they do their operations will be one of your top reads probably. And if you already have your DevOps engineer in the team and it didn't already go to the unwanted extreme, then don't kill him, please, because I said so. Rather, use this fact and learn from him, and because you're at a great position, perhaps, and also teach him your stuff. Make him learn about the application. There may be some opposition, but it will help him to learn about programming a little. But I will get to this a few slides later. So what we did, this will be really quick. I just want you to get a general feeling of what we were dealing with. So really what I want to tell you, this was a very run-of-the-mill application. It was 5 years ago. Few VMs on a on-premise server with Apache Tomcat, a few applications running on it, Nginx for good measure on the same node. Then some reverse proxies, a software proxy and a hardware proxy, one of them caching, doesn't really matter. But, like I said, run-of-the-mill, a SQL database. And what perhaps was not that usual is we already had some stuff in AWS because of the previous attempt at migration, kind of failed. So yeah, also had to do this. And we were, me and 3 developers, kind of, but it really boils down to that. Our mission was to fulfill the company-wide migration to Azure. Why? Not because Azure is better than AWS, but because of partnership with Microsoft. So we, as a company, we had much better prices with Azure, so we wanted to finally make the move to cloud. As a company, also, there were talks about embracing the DevOps culture and so on. So we either had, we previously didn't have a DevOps engineer on our own. There was a DevOps team. That's actually the worst option. But as the migration started, the DevOps team was disbanded. Everyone got one of the engineers for them to own, and we didn't get any because there were not enough. And we were told to either hire one for any cash needed, or we can learn the stuff. And we were crazy enough to want to learn the stuff. We were given help. A lot of, well, consultants from Microsoft helped us learn all of this stuff. So I'm not here to tell you that we learned it all by ourselves. Also, we were in a big company, so yeah, you can imagine. Note that we were also told that we will need to take care of operations and on-call duty. So whatever we migrate, if it will be unstable, it will bite us in the ass, or we may decide to leave the company. That's always the option, but don't do this. Don't do stuff like that. And yeah, I'm not going to really very much to the application as we had it, but I wanted just to show you that it was nothing out of the ordinary, even very boring. So how did we do it? We started really well before the migration to Dockerize our stuff for testing purposes. Having it containerized, make the testing easier, and I advise you to do it. Even if you don't run containers in production, containerize either way because it will help you a lot. That's simple, step 0. Now the fun starts. So choose your deployment option, and by that I mean either, well, plain VMs, really, and probably if you're just starting and you don't have much time, you want to go fast, perhaps you should start with this. We had some time, and as I said, we needed to take care of the on-call duty. And if you want to make sane operations on VMs, there's actually a lot of work. A lot of stuff you need to get right. And our conclusion was that perhaps no VMs. Containers as a service, I'm just showing you here Azure and AWS because I know by now Azure a lot, I think. AWS, kinda. Didn't learn so much about Google Cloud Platforms, so I'm not going to just show you stuff from the internet, what would this make, but obviously it has equivalent services. Containers as a service may work for you very well. It's perhaps if I would start my own little thing, perhaps this is what I would actually choose right now. But it was kind of not mature so much back then, and also had problems with the cloud company infrastructure, with Express Route, cloud VPNs, and so on. So we tried it. We ventured into this path, tried it out. We basically had issues. It could have been us, but decided that we want to go this way, basically. So a Kubernetes cluster, a managed Kubernetes cluster that you don't install yourself, you just run stuff on it. And there's a lot of fear-mongering about Kubernetes, some of it justified, because you will have to learn a lot and read books about it and do your homework if you want to be successful. Don't be fooled. But I think the fear-mongering is really a little bit too much at this point. There are options where this could actually work, and I think it worked out very well, but I'll show you the results later. Then there are platforms as services that actually mean a lot of different things, because PaaS services are kind of similar but also quite different to each other. also at this point, 5 years ago, they were not as mature as we would have liked. App service, I'm not sure if it was available even, maybe in preview. And functions as a service, I think it's great if you want to cut costs. If you just want to make it easy for you, I don't know. We looked into it. Our conclusion was that it's not, but I want to tell you that I'm not telling you choose Kubernetes, not at all. Just evaluate all of these options, learn about them if you want to go this way. That's the actual step. Yeah. One important mention, a guy called Daniel Vassallo worked 8 years in AWS. Has written a little book called AWS The Good Parts. Makes a good, beyond the book, there's a Twitter thread by him summarizing some tips using AWS. So the general gist is that you should probably stick with the most popular services, and there's a lot of truth to it, although I think he went a little bit extreme. But he also mentioned simple web applications. But the general idea is quite true. The less popular the service, the less stable it will probably be. And it's like this on every cloud, not just because it's Microsoft and with Azure. And yeah, there's definitely some truth to it. On the other hand, found another interesting look on the stuff, and that basically Kubernetes is really the future because it's cloud agnostic. Abstraction over cloud services in a way, and we just need better Kubernetes tooling. And platforms as a services are great, but we would rather have, Kubernetes more on the front here. So that's also an interesting point. Yeah, that would be step one. Step two, once you've chosen it, build it, and how do you do it? Well, start by clicking things out, discover stuff in the graphical user interface. Once you learn new stuff, or if you want to learn new stuff, you get back to GUI and click a bit more. But if you want to actually run it and have it reliable, you can rely on what someone has clicked out. It will very quickly get out of control. And you probably should have a job that cleans out everything that is not managed by infrastructure as a code, just clicked out in the GUI. So there's that. Scripting, and this may mean direct API calls, but it's not very popular. I've seen a popular approach where you would script usage of CLI tools. Bit recommended, but I personally advise against it because, in my experience, 99, even though the previous talk, if you've been here, made very good points about how you can use unit testing tools in bash scripts, and if everyone would use it, perhaps it would be much better. But right now, 99.9% scripts out there in the world are shit. Unmaintainable for anyone but the author, and the next day also for the author. It's just helpless. I mean, DevOps engineers are typically not very good programmers unless they were programmers previously, but this doesn't help really much because if programmers get to do bash scripts, suddenly they forget everything about clean code, testing, and stuff. They just go wild on the scripting. And a little spoiler alert here. I think part of why we actually succeeded because we did is because in the end we had infrastructure as a code, CI, CD, with absolutely not a single bash script, only YAMLs and declarative tools. It's possible, and it was so great. So, as infrastructure as a code, without scripting, you have cloud native tools. Some may be better, CloudFormation, some may be worse, Azure Resource Manager. So as we were forced to use ARM, didn't really like it. We have chosen to go yet another way, so with Terraform. And it was also popular in the company, so it was a natural choice for us. And In this class of tools, you don't really have much of a choice. You have either Terraform or Pulumi. And Pulumi set out to solve the Terraform problem in that it's lengthy, it's a lot of code to actually get simple stuff done. But let me tell you this, all of this is infrastructure as a code. These are declarative infrastructure as a code tools. And Terraform, yes, it's lengthy, but it's very much, sorry, wrong slide. It's very much like Maven. And a little thing on Maven. When Java engineers, I have yet to see an exception to this. When Java engineers start programming, they love Maven because it's the first tool they learn usually. Then they hate Maven because it's XML. To declare dependency, you have to put 5 lines usually of code. And with Gradle, it's just 1 line. And then they love Gradle, or SBT, or Bazel, or something. But a few years later, they love Maven again, because Maven is so dumb that you can't really make it unreadable and unmaintainable. You really have simple tooling there, unless you go some plugins that let you script things, but that's really breaking out of Maven. And Terraform is very much like that. You have to embrace its declarativeness to find out that it's actually a great tool. And yeah, at this point, you have to have some kind of CI. And it's really not that important. Every tool will work, but what I'll tell you is the most sane flow is whatever ends up with containers in the registry. You are there, you're ready to set out to whatever's next. And that's deploying. And now taking a step back to Terraform. This was our first approach, and I see this happen a lot, so I'll describe it a little bit. We started out with we started out with a leveled approach to Terraform configs. Terraform config is a thing you run at the same time, right? If you didn't work with it. So we had a config for things that are done once per world, things that are done once per subscription or account in AWS, things that are done once per environment. For us, it meant, for example, blue-green on the same subscription, or a dev environment for a single developer on the dev subscription. And then there was config for creating Kubernetes cluster and infrastructure stuff in Kubernetes. I don't know how to call it, but things like Nginx ingress controller, basically things that are taken from the internet and need to be on the cluster. And then finally, there is a level that deploys our application. So the bottom. So this, we thought this was great because we have a single tool, Terraform, that does everything from creating the infrastructure from scratch to deploying the application. And so the deployment looked like this. New container registry. You actually have to manually run we started with manually, right? Select environment to which you want to deploy to, run CI runs Terraform apply, Terraform applies runs Helm apply, and Helm applies changes to Kubernetes. In theory, it should work. In practice, we tried it out. We went with it to production, actually. We went, not sure if we went live. I think we went live with that version, but it was very hard to maintain. Whenever we had to add new microservice, it was a lot of code. Perhaps we could optimize it, but it just proved hard for us. At some point, we decided to remove it all the Terraform code, start from the beginning. Approach number 2. So these were actually directory names. Modules, what's in dev subscription, what's preprod subscription, prod, and external things, so things that are outside of Azure. Some software as a service things like black box monitoring stuff. Not important at all at this point. So the main difference here is that previously we had levels of config that were parameterized, because coming from programming, you don't want to repeat yourself, right? You want to run the same thing. Each environment is kind of the same, do some parameters and stuff. And a lot of people do it like this, and a lot of people are successful with it, particularly if well, in the end, they always use then the Terraform wrappers like Terragrant. And Terraform wrappers, you may like them, okay, of course. We didn't. Basically, it boils down to that. With this thing, it was plain Terraform. And what's great about Terraform is that at any point in time, you should have files in your Git that represent the current state of the system. If you have Kubernetes config that is parameterized across environments, then the files don't show what's currently on the system because you don't deploy on all environments at the same time, right? You deploy to dev, check if it's okay, then to prod probably. You don't need pre-prod at all. It was kind of, never mind. So this simple and stupid as it is, really worked out well. We used heavy use of modules, and in the end, we didn't have any repetition. It was still dry, which we couldn't fathom at the beginning, how far you can go with modules. But yeah, it's possible. So CI looked similarly. Containers in registry, then manually you run Helm file apply, and this is another tool that runs Helm. Helm file shows you diff, quite like Terraform, if you know. If you don't, never mind. And review the changes in the diff and accept them. So it's another tool that runs, another big tool. But the difference is being Terraform is a big, complicated tool that runs Helm, which is another big, complicated tool for different things. And Helm file is that simple one. So it's kind of like a good wrapper, I would say. I don't know. Or maybe it's just better. I don't know. It worked out for us. So really, the conclusion is try different things, fail, rewrite from the ground up. It's okay. Do it a lot. Learn your stuff. And observability. At this point, I won't tell you much about it. I won't talk your ear off, because whatever you choose at this point depends heavily on what you have chosen previously. But if you have chosen the same path as we did, there's a little thing called Prometheus stack, and you will grow to love it as your own child. I know. It's a great observability, almost complete observability stack. That's simple to install. You have to learn it, of course, to operate with it, but it made a lot of our work simpler. And then I'll give you just a starter pack, and it's from the SRE book that I mentioned you should read, is 4 golden signals. So latency, you know what latency is, request per second, errors, whatever that may be, and how many resources are left. And you measure it. If you don't want to measure these 4 things, all of them, no exceptions. Have sane alerting based on them, and you should be at least on a good starting path, on a very good starting path. And yeah, read your stuff. So to reiterate, Dockerize, choose the infrastructure type. Infrastructure is a code, CI, CD, observability. That's basically your recipe, or the path that we went with, like I said, for developers. And quite some time. It actually took us about half a year, 7 months to get to go live with that, well, not that much complex of application, but it had some resource usage, so whatever. And these first things, it's not steps that you do one by one. You do them kind of at the same time, and then you rinse and repeat and improve them constantly, and the stuff never ends. But it's okay. So what did it result with? What did we manage to do in this time, in that time? It's infrastructure, time to production went from 1 to 3 days to half an hour relaxed with all the tests running. And tests, I mean integration tests that created test nodes on the test cluster to test against with really end-to-end tests. Well, you may have seen that we didn't have testers. That's true. We had, so we made the best use of our resources, have just a few scenarios, but critical ones, and our tests work quite okay. But if you have QA engineers, I mean, make use of them, obviously. And 1 to 3 days, it was previously you had to make a deployment, you have to create a Jira issue that you want to deploy your application, go to a meeting that happens only twice a week. On that meeting, you say, I need to deploy my application. And then a guy that runs the meeting says, why? Why do you need to deploy it? Well, because it's part of my job. OK, so the process was devised to help against to help integration between the different services, but the idea that one person running those meetings would understand all the services in the company was crazy. He focused on his favorite few ones, and he didn't know nothing about ours, so he just, did what he had to do. And then once the meeting is over, the DevOps engineer from the DevOps team would, the next day, always the next day, to give it some window of time, do the deployment. Quite crazy for even the simplest stuff. So the feedback loop was non-existent. Infrastructure as a code. So previously there was apparently some infrastructure as a code written in Puppet that no one understood. I mean, no one. The DevOps engineers knew parts of it, and together they could manage it. But, well, no one in the team was able to. Then we went to Terraform that covered everything, and every team member, not everyone loved Terraform, like I did, but everyone was able to make the changes, do his work, and this resulted in disaster recovery that previously no one even tried to, and we just prayed to software gods that a disaster won't happen in the on-premise, on the on-premise servers. To what we've measured on a little thing called Game Day, where we simulated the disaster recovery and had to rebuild from the ground up on another subscription. So we measured this at 2 hours, which I think was kind of good. You may think it's not so great, but it was also measured this. We found problems with disaster recovery, things that could improve it. We did improve it. We didn't measure it after, so 2 hours easily, not to lie to you right now. Dependencies, of course, the DevOps team, and there's actually another DevOps team that was called the infrastructure team. And it went to, well, no dependencies and no single point of failures in the team. I could, as a team leader who did actually a lot of this DevOps stuff, because I had small stuff, right? So one-on-ones and accepting vacations didn't amount to a lot of time of my work. And I had, unfortunately, the most experience in the team, so yeah. But anyway, yeah, I could go to vacations for 2-3 weeks, and nothing bad happened. Nothing to report. Everything went well. There was nothing good that you're back. You can finally solve this issue. No. And these were developers that had 1 to 6 years of experience, which doesn't tell you much, but tells you something. Changes to infrastructure. We previously, to request a VM, we had to, it was basically weeks of time not to get into processes. It was crazy. If you think you can improve your application, if we have something in the infrastructure, well, it was hell. It was hell, baby. And then we went crazy on trying out new stuff. Kafka and migrate actually got to production in matter of months. I mean, to production, not to trying out. To try out Kafka, you just do Helm, apply, stream the Kafka operator, and you're done. And you have Kafka running, well, just for tests at least, right? It's not production ready, obviously, but you can try it. MQTT delivered as part of customer project on the product that we ran. Also quite a success. Databricks, that was tried out, but tried out easily. Yeah, we could have some fun. Basically what I think is called self-serve model. And high availability and scalability. What I didn't show you was were failover servers on-premise, but that's it. In the cloud, well, scalability possibilities are really endless, and we make really good use of it. Not to bore you to death, but that's basically it. I mean, we could do whatever we want. And like I said, your mileage may vary. And it may not work out so well for you. And definitely making the same choices as we did will probably not work out for you. But what I'm telling you is that because, well, we did it, it's quite proof enough that it's possible. You can do it, even if in a smaller team. Perhaps having too big of a team would be too much of a hindrance. With smaller team, you would go slower, but you would finally get it. If there was like 10 people, I don't know, maybe it would be too hard. I don't know, or not, or maybe it's possible. I don't know, but yeah, because we did it, you too can do it if you like this way of working. If your DevOps engineer holds you ransom and doesn't work to help you deliver features because he said, I need to do this crucial network stuff or everything will burn to hell. Yeah. If you never play around, you never find out. Break things and learn things. And don't be afraid too much, because unless you're working with sensitive data, if you are, then you're in a much worse position. We weren't. But if you're not working with sensitive data, even if there is a fail, just try defend yourself against the most dangerous stuff, and don't be afraid too much to experiment. On the pricing side, yeah, you have to have some stuff like policies that will at least alert you if things go out of control. But don't stress too much over pricing it too much. There's a healthy level of stress that you should have at all times. And scripts suck. I declare that things rock. That's me. And yeah, we actually ended up a lot earlier than I imagined. My first try was at full hour. So let me show you the bonus slide, which is our ops repository. Don't be afraid, I'll tell about it quickly. So there are really 3 things to it. The Terraform stuff I've basically shown you. It was like this, we went with this production. There was a little directory called subscriptions that held custom YAMLs with values that parameterize the Terraform stuff and the Helm stuff. Some values were actually used in both places at once. So stuff like how much CPU on prod, how much CPU on dev, what's the URL here, what's the URL there, and so on. And also secrets. We had HashiCorp Vault eventually, but because it was not at the beginning, we started with something called Mozilla SOPs. And to make long story short, it's a tool that allows you to hold secrets in Git. So if someone tells you never to store secrets in Git, well, there's a caveat. You can use SOPs and go crazy. But really don't go crazy. Be aware of what you're doing. Anyway, yeah. So finally, with Helm, most of the stuff, Helm charts were done properly. So Helm charts were in a repository, but ACR, Azure Container Registry, as we started with it, didn't play well with Helm charts. So some stuff were inline, and Helm file is actually works quite well with both inline charts and charts from repositories, and charts for things like Nginx and Kubernetes stack. And also what we had in the repository was actually a template for values that there was because the template allowed us to have different values per environment. So a single thing called thing Helm file YAML. I mean, thing is the application name. I just obfuscated it. Described all the Helm deployments to be made on a single environment. So disaster recovery looked like this. Terraform apply, wait for it to go up. Actually, you have a couple of minutes, good couple of minutes. And then Helm file apply with parameter prod, preprod, or whatever. And you're done. All the applications, all the infrastructure is there. We didn't actually did this in CI. So it was kind of not continuous if you think about it. What I also want to tell you is typical imperative script running continuous integration tools are not great to run Terraform. You should either pay for Terraform Cloud, or there's a little open source thing called Atlantis CI. And it actually works just as well for Terraform as it does for Helm file. So yeah, that's how we did it without any scripts at all. If you don't count, well, script in the CI to produce the Docker container for each microservice. And yeah, that's it, with some time for questions still. Thanks.